In this episode, I will discuss OpenGL Superbible 7th edition. In preface, I would highly recommend you to read preface because in the preface, this book explains how to best use this book. When we read a book, we have to read from cover to cover. Also, in chapter 1, you should learn what the graphic pipeline is and how OpenGL relates to it, the origin of OpenGL and how it came to be the way it is today, some fundamental concepts that we will be building on throughout the book. In chapter 2, our first OpenGL program, what we will learn in this chapter: how to create and compile shader code, how to draw with OpenGL, how to use the book's application framework to initialize your programs and clean up after yourself. OpenGL Superbible 7th edition. This book is super good to teach yourself OpenGL. Hi everyone, my name is Thomas Kim. Today is September 27th, 2022. This is my 83rd episode for C++17 2023 CUDA SQL OpenGL OpenCL TBB. This is my third episode about OpenGL shaders. OpenGL Superbible 7th edition, second episode. I will discuss Chapter 2, OpenGL Super Basics. The title OpenGL Shaders 3 suggests that there are previous videos. I assume you have watched previous videos listed here. OpenGL Shader 1, OpenGL Shader 2. Also, I assume you have watched from episode 54, C++ library extensions in Visual Studio, up to all previous episodes, episode 82. If you missed one of these videos, you may have difficulties following my current and future sessions. Now, open up Microsoft Visual Studio. Go to File, New, Project. Select OpenGL Superbible 7. Click Next. Make sure you selected your working directory. Select folder. Solution name 083. OpenGL Superbible 7 Solution. Accept default project name. Click Create. Here, you should be able to find 3 CPP files. alien.cpp. This file is disabled. Source.cpp. You should be able to find this code. Press Ctrl F5. It should build and run successfully. Now, class OpenGL app public SB7. Base class is application. Obviously, SB7 is namespace. Application is our base class. Public void render double current time. Override. Static const GL float red. We are initializing an array. 1.0 app 0.0 app 0.0 app. The last color is alpha channel. red, green, blue, alpha. Alpha equal to 1.0 means opaque. Don't miss semicolon. GL clear buffer FB. FB stands for float vector. FB stands for float vector, which means array of floats. Now we select buffer GL color. Draw buffer, we are using single draw buffer for the time being. So pass 0, default draw buffer. GL float, this is pointer. We can pass red, semicolon. Now here we will disable it. H instance, H instance 2 colon get module handle. We pass null. WinMain H instance null. Command line, we will pass null. SW show. Press Ctrl F5. Sorry, I missed one thing. The message says unresolved external symbol WinMain referenced. It means declare main. We pass OpenGL app. This macro creates WinMain. Now press Ctrl F5. It should build successfully like this. Now close it. Close it. From this book, OpenGL Superbible, click this button. You can find listings, our first OpenGL application. We have just tested this code. Now, listing again, animating colors over time. We will test this part of code. We will start from scratch. Now close it. Right click, add new project. Select OpenGL OGSB7. Click next. Just accept default for project name. Click create. Right click, set as startup project. Open source.cpp. Class OpenGL app public SB7 application. This is our base class. Public void render double current time override. GL plot x equals 0.5 times SED cosine current time. Copy, paste. Y sine. Please understand that value x can be greater than equal to negative 0.5. Also y less than or equal to 0.5. We can say static constant color GL plot color. This is array. Don't miss semicolon. X plus 0.5 f. We will put typecasting here. GL plot like this to suppress warning. This is purely for suppress warning. Y plus 0.5 f, 0.0 f, 1.0 f. So we defined color. Now GL clear buffer FB, GL color throw buffer 0. Color. Don't miss. Declare main. We pass OpenGL app. This macro defines WinMain. Please watch this pop-up window. This macro defines WinMain, then creates an instance of OpenGL app, then calls run method of the instance app. Now here H instance to colon get module handle. We pass null. We call WinMain H instance null SW show. Press Ctrl F5. Something is wrong. Now close it. Sorry, I have to remove it because static is initialized only once. Remove like this. Ctrl F5. You can notice the color change. Now close it. I have just covered this part. This is listing 2.2. Now scroll up. We will be using shaders. You can read this book. Go back to Visual Studio. We will create new project. Now close it. Right click, add new project. Select OpenGL OGSB7. Click Next. Accept default for project name. Click Create. I will fold it up. Right click, set as startup project. In the shader files, if you double click it, you can read this documentation. I implemented these files in episode 77 and episode 76. Control click on October 6, 2020. I filmed this video. If you scroll down, you can find episode 76, episode 77. I will copy this video link for your reference. Save. Close it. Right click, add new item. Select utility text file. The file name point.vrt. Click Add. Right click, add new item. Select utility text file. Point. Flag. Click Add. I will arrange side by side. Version 450 Core. We are using Core Profile. Void main GL position. GL position is built-in variable. Backfor 0.0, 0.0, 0.5, 1.0. This is normalized. Here, version 450. We are using Core Profile. Out, backfor color. We declared output color. Void main. This color is output. Color backfor 0.0, 0.8, 1.0, 1.0. So this is fragment shader. This is vertex shader. Save all. In this PDF, this is vertex shader. And this is fragment shader. Listing 2.4. Our first fragment shader. Also, listing 2.3. Our first vertex shader. Now save all. I will close it. Close it. Open source.cpp class OpenGL app colon public SB7 application public void startup override. This is virtual function. Void shutdown override. This is also virtual function. Protected. In the startup, this rendering program create program. We pass point vertex shader point vertex shader point fragment shader. Of course, we need to define GL unsigned int rendering program. We will simply initialize to default value. Rendering program. I misspelled or I fix my typo. Then we have to shut down. If GL is program, we pass rendering program. If it is GL true, then GL delete program. GL this rendering program. This function will be called when our application shut down. Now GL create vertex arrays. This is plural. We pass 1. We need to generate or retrieve unused vertex array object name. I say GL unsigned int vertex array object. I will set it default. I pass it as a vertex array object name. We acquire an unused vertex array object name from OpenGL runtime. after use. If GL is vertex array, we pass this name and paste it here. GL true, GL delete, vertex arrays. This is plural. One vertex array object. Because GL true, this is set to value 1. Of course, we can do this and do this, but I would do this to help you better understand and make ourselves familiar with GL macros. Now we have to bind. I would say GL create vertex array. This is the same. GL bind vertex array. We pass vertex array object name. We inform OpenGL runtime to use or activate our vertex array object or this. Up to this point, I covered this part of code, or listing 2.6. We need to implement one more function. Here, void render double current time override. Constant GL float color. This is array. Don't miss semicolon. GL float SED cosine current time. Please note that this value can be negative. We want to make it positive. So 0.5 times cosine plus 0.5. This should be plot. Copy, paste. This can be sine. We make the color value red greater than equal to 0.0 less than equal to 1.0. This is green. then 0.0 f glue component 1.0 f alpha component. We defined color. Please understand that we used constant. Constant in C++ can be initialized at runtime. I said at runtime, as well as at compile time. So C++ constant is very ugly mistake. Simply remove it. Of course it works, but I will remove it. glCreateBuffer fw gl color 0 color. We need to use GL use program. This rendering program. We inform OpenGL runtime to use our vertex and fragment shaders compiled and assigned to this program. That means we can use multiple different programs selectively. Now GL draw arrays. We are drawing GL point 0. This is count 1 point. Now scroll down. Don't forget we have to declare main by passing this class name like this. Right click, go to definition. This is defined as a macro. A is class name. In function WinMain, it creates an instance of A. I will arrange side by side. We passed OpenGL app. This is A, an instance of OpenGL app is dynamically created, then calls member function run. When this member function run returns, we delete app. Then the program ends. Now close it. Now we can try another method. Properties. All configuration, linker, system, we can select Windows subsystem, Windows. Click Apply, click OK. Press Ctrl F7 to compile. Press Ctrl F5 to run. Sadly, we cannot see the point. Now close it. I made a simple mistake here. It should be points. Press Ctrl F5. I can now barely see the point, but it's too small. GL point size 40.0 F. Ctrl F5. Now I can see the point. Very big point. Now close it. Please understand that this main function is bypassed. Right-click, Properties. We can select Not Set. Click Apply, OK. Press Ctrl F5. Here, disable it. H instance, get module handle null. We can now pass WinMain H instance null SW show. We can clean, then project only rebuild. Press Ctrl F5. It should build and run successfully. The reason I use console window is that we can use the console window to spit out debugging information. Now close it.